Bismillahirrahmanirrahim. Assalamualaikum. I'm your teacher with the 7th lecture of Basic Mathematics. The course outline of this week is, which we are going to discuss, is system of two equations and two unknowns, and the second is system of three equations and three unknowns, and the third one is Cramer rule. Then we will discuss row operation and row echelon form, and we will discuss the augmented matrix. First of all, we are going to discuss system of two equations and two unknowns. We know that the two linear equations in the same two variables such as a1x plus b1y is equal to k1, a2x plus b2y is equal to k2 is called the system of non-homogeneous linear equation in the two variables x and y if the constants terms k1 and k2 are both are non-zero. If in the system this system k1 and k2 are equal to 0, then it is said to be the system of homogeneous linear equation in x and y. Now we are going to discuss the system of three equations and three unknowns. Three linear equations in three variables such as a1x plus b1y plus c1z is equal to k1, a2x plus b2y plus c2 is equal to k2, a3x plus b3y plus c3z is equal to k3 is called a system of non-homogeneous linear equations in three variable x, y and z if constants k1, k2 and k3 are not all zeros. If the system in this system k1, k2 and k3 are equal to 0, then it is said to be the system of homogeneous linear equation in x, y and z form. A system of linear equation is said to be considered if the system has a unique solution and it has infinitely many solutions. Again, I'm repeating the definition. The system of linear equation is said to be consistent if the system has a unique solution or it has infinite many solutions. Then we said that the system is consistent, and a system is said to be inconsistent if system has no solution. And the system consists of three equations is three variables, so it is called 3 cross 3 linear system. But the system of the form, this form, is named 2 cross 3 linear system. There are two equations and there are three variables x, y and z. That's why we call this type of system is called 2 cross 3 linear system. Now we are going to discuss the definition of augmented matrix. For example, we have a system equation. There are three system equation, x1, x2 and x3 unknown, and 3, 3, 42 are constants value which are not equal to 0. And when we write this system of equation in matrix form like this, we will write the coefficient of x1, x2 and x3. There is the coefficient of x1 is 1, the coefficient of x2 is 3, and the coefficient of x3 is 2. So, and we write here 1, 3, 2 and equal to this 3. When we write this system of equation in matrix form, then this is called augmented matrix. Okay, now there is a rule which is a Cramer rule. Before this, we in our previous lecture we will discuss there are method with the in which we will discuss the solution of system of equations with the help of matrix, in which we find the determinant and adjoint, and then we will find A inverse. Then we multiply A inverse with B and finally calculate the value of x1, x2 and x3. But there is another method which is a Cramer rule. With the help of Cramer rule we can also solve the system of equation, and then we will find the their solutions. So now we are going to discuss the Cramer rule. What is Cramer rule? Consider a system of equation. There are three unknowns, three variables x1, x2 and x3, and the constant is b1, b2 and b3. There are three linear equation in the three variables x1, x2, x3 with the coefficient and the constant terms in the real field are. We write the above system of equation in matrix form. Ax is equal to b, where the value a is equal to a11 plus a11, a21, a13, a21, a22, a23, a31, a32, a33 in matrix form, and the value of x is equal to x1, x2, x3, and b is equal to b1, b2 and b3. We know that the matrix in equation 2 can be written as x is equal to A inverse b if A inverse exists. We have already proved that A inverse is equal to adjoint of A divided by determinant of A, and adjoint of A is equal to this, and thus we can find the value of x1, x2 and x3. Okay, in Cramer rule, first of all, we multiply the first this matrix A11. This is the first column, and we multiply the we interchange the first column with the constants values. For example, we discuss in here. Here we can see that we interchange the first column of the matrix with the constants of which appears after the equal sign. This one b1, b2, b3. We interchange the first column of matrix with b1, b2 and b3 like this, and the determinant of this matrix then and divided by determinant of A. Now we can calculate the value of x2. For x2, we interchange the second column of matrix by constant column, and then for finding the value of x3, we interchange the third column of matrix with x3. The method for solving the system with the help of results 1, 2 and 3 is often referred to as a Cramer rule. This rule is completely explained with the help of example. We are going to discuss example. Use Cramer rule to solve the system. Here, first of all, we will find the determinant of a matrix A, which is first of all we convert it in augmented matrix, where matrix A will be equal to 3, 1, minus 1, 1, 1, minus 2, minus 1, 2 and minus 1, and we find the determinant of matrix A, which is equal to 9, and this is not equal to 0, so we can find the value of x1, x2 and x3. For x1, first of all, this matrix we interchange the first column with constant values which appears after equal sign. Instead of 3, 1, minus 1, we put up minus 4 and 1, and remaining matrix will stay same as. And then we find its determinant and divided by 9, the value will be 1. This is the value of x1. Now for finding the value of x2, we replace second column of above matrix with minus 4, 1, and for finding the value of x3, we replace third column of matrix with minus 4, 1, and minus 4, 1, and then we find its determinant and divided by 9, and we can calculate the value of x2 is equal to 1 and x3 is equal to 2. So here we have a solution. x1 is equal to minus 1, x2 is equal to 1 and x3 is equal to 2. This is our Cramer rule. Now we are going to discuss the next row operation with and row echelon form. We explain row operation or row echelon form with example. There is example: reduce the following matrix to row echelon and reduce row echelon form. which is this is the matrix, and we want to make its maximum entries 0. For this we apply different operations on the row, or in which, for example, in this, first of all we interchange first row by second row, 1 minus 1 2 3, the second row and first row, there are we interchange the second row with first row, then we multiply first row with -2 and then add in second row, and then multiply -3 with the first row and add in R3, there will be this. And after applying some row operation, we get a new matrix, which is 1 minus 1 2 3 0 1 minus 1 3 0 0 1 minus 1. In this method, first of all we make first entry 1, then try to make entries 1 minus 1, and the main purpose of this method to make maximum entries at 0. So this method is called row echelon form. And there is this is the end of our lecture. We will discuss next topic inshallah on next week. And there is an assignment which you have to solve for your practice. Solve the following system of linear equation by Cramer rules. There are 3 system of equation which you will solve by Cramer rule, and this is your practice question. And with this all, goodbye, take care, Allah Hafiz, best of luck.